Hi folks, we've got a chunk of aluminum and we've got the skill sets of Sam from Merchant House Design, who put together this fuel cap. So we've actually done a number of videos on this. Here's a link to the playlist. I really want to give a thanks to Sam. Here's the website for his company. This is such a cool thing about how the world we live in, because he designed this from a photo. The videos are amazing. We collaborated over the Fusion 360 over online, and now ball's in my court. So we actually made a few of these, you can see here. And one of the reasons I've been kind of dragging my feet on this project was I wasn't able to get a few things nailed down. I think, knock on aluminum, I've got this figured out. We need to make a form tool to create the custom thread pitch here, and we're going to remake this tool today out of a piece of W1 tool steel, and we're going to use my new Sandvik radius groove tool. I think, again, knock on Sandvik, that's going to work better. Honestly, these weren't bad. I just wanted it to be a little better. And then the other problem I had was just a bad 3D recipe right up here. See that pocketing? So I want to try to get rid of that. We're going to powder coat it, come back and engrave the logo. Should look pretty good. First steps, head over to the lathe, folks. Welcome to another Wednesday Widget. This is the groove for the gasket seal or whatever you call that. It's actually off the shelf part that Sam found. I assume just hit like an AutoZone, which is perfect. So this will just help seat that and obviously give you a good seal. Curious to see when we turn the, oops, is that cut? Is he gonna do 2 passes? Yeah. I'm curious to see when she stops spinning to look at that surface finish. I would assume flood coolant would get a little bit better than the fog buster, but it really, with the flood coolant, makes it impossible to film and enjoy it on the machine at least. And finally, a drill. We're going to drill this hole for a couple reasons. One, it'll be a place to hang it when we powder coat it, and it's also going to be really helpful for the fixturing. Perfect. That'll work for me. Damn, that's great. Awesome. Okay, so we just did the first stop, which faced us off profiled, cut that little groove, which is supposed to be rounded. I think the square shoulder is going to work. If not, we'll fix it. And drilled that hole. Now what we're going to do, we're going to flip it in the forejaw, and we'll face and profile that other side. Then we're going to switch over to our piece of W1 and make our new little form tool thing. We need that to cut the threads. While we've still got some scrap material down here, we'll stick it in the flex arm with a 1/4-20 and taper. Perfect. Arts and crafts time. Need some shim stock. That'll get me there. It's like 0 chance this goes back on. That wasn't so bad. Don't cut yourself. That's my big takeaway here. Okay. It's really only 2 jaws here that are out. So if you take a look in Fusion, our Z0 is actually back here, because I don't know and I don't really care what the rest of this is. So let's just stick my parallel back in here. This is why I didn't want the shim stock sticking out. And you can feel the parallel, how snug it is, and whether that's a good read. Assuming I don't crash my drill bit here. Get close, and then we'll do the paper test. There we go. A little too much stock defined in Fusion there. Oh, isn't that awesome? Really, I feel like I'm starting to learn lathe tooling. We're breaking chips, we're taking a pretty decent cut. 3 inches, 4 inches isn't too bad on the diameter. You know, we were running those 6-inch parts, and we had a lot more trickiness figuring out torque at the lower RPMs for the bigger parts, but this is aluminum too. Who is it? Somebody said Tom Lipton maybe has a shirt or something funny that says, you know, everyone's a hero in aluminum. Look at that, hell yeah. It's like glistening. It's awesome. So the roughing passes, and then a finish pass any second here. Boom. So then this automatically slows down to 4 thou per rev, which is great. Gives you a better service finish. Even though actually most of this, man, so that's the downside. The chip breaker's not right for that feed rate on the finish. Hopefully it won't mar it up. I was just gonna say most of this gets remachined anyways here in the mill, but 2 steps forward, maybe 1 or half a step back. goes back to our lean movement, which is no one really cares about using pliers to do this. You care about having to walk or walk across the shop or look for the pliers, you don't know where they are. They're sitting right there. It's the no-brainer. So that's the goal, folks. Again, I've never been a big fan of the MBA, classroom or like textbook, blah, blah, blah. Let's talk about stuff for 5 days straight. Lean, more just like, let's be smart. Okay. Good news is I have no complaints about that surface finish. Rock on. Okay, now we got the hard part. Let's make that tool. All right, we've done our 2 lathe parts. Now it's time to make the form tool. And we did a video actually on this before, so we're kind of redoing some of it, but I'm really excited. So in Fusion in the cam side, we've actually got all of our CAD data here in this component. So if I expand it, you can see I can turn off the fuel cap. So it's kind of, my model's kind of empty, and I can turn on the form tool. So this is our little Pac-Man form tool thing that we're going to try using yet again. Should work pretty well. So what are our ops here? It's relatively, get oriented, straightforward. We're going to face it, drill a hole through it, grooving, this is where all the magic happens, and then part it. Quick sim, face. We're doing everything with the Sandvik tool, obviously, except drilling. Puts a hole through the thing. And this is the critical part here. I'll be cutting some air, that's okay. Roughs it out. I'm really excited to try the radius nature of the Sandvik tool because unlike the previous tools that we used that were either square-shouldered or maybe they had a 4th thou radius, this should do a better job. So it does all that, and then clean up. And now it's going to part it off, and we'll use a surface grinder to flush that backside edge. That way the 2 faces are parallel. Perfect. Boom. Select the op. Post. Post. Rock and roll. W1, I estimate probably takes me somewhere between 3 and 5 A-bombs right now to dial in a 4-jaw. This is a little bit nice because I can cheat with the kind of self-centers a little the way the 5C system works. Actually, maybe not as much as I thought. Disregard that. Loosen on the low, that's what I always say. The hell am I doing? Can't machine this thing with that much sticking out. Hold on. I've got it on the surface grinder. All I'm doing is basically facing off the opposite side, the parting side, which just confirms those two sides are parallel to each other. Important when we go to mount it on the little mandrel. Now we need our little Pac-Man shape, so we'll stick it in the Tormach mill. We'll do an adaptive with a 1/4 inch end mill to hog it out. We'll do a horizontal, which will clean up the floor, which is the cutting face, and then we'll do a 2D contour. Honestly, probably not necessary because this is all backside relief right here. Let's take a look. Hope it's good. Hope it's good. Okay, folks, RFI announcement. That means really important. The first one of these I made, I countersunk my piece of tool steel, and I thought that would be all nice because it'd be flush in the end and blah, 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 and I goofed because that meant we had to hold the tool like this, and that meant I had to turn the lathe spindle backward, which meant I had to thread from the inside out or away from the headstock. Ended up being a not fun nightmare, not fun. So this time, we've got the ability to switch the tool, but we're gonna mount it like this, and we're actually gonna hold it in one of these tool posts down here, and it's gonna cut with the the spindle turning normally, which is actually, sorry, normally is counterclockwise, forgive me. And then we can thread from that tailstock to the headstock, should be much better. Sorry that I'm crouching down. So all I do is we're just screw this button head cap screw down here, and then just gonna drill, ream, and tap in a set pin. How about that? It snapped off too. Perfect. I was gonna go cut it off. So we've got our guide pinned on here. We're reusing the arbor from last time. How do we get this thing leveled? It's actually really easy because we've got one of these inexpensive angle finders. And the turret, or the whole the x-axis here is actually at 45 degrees. So all I've got to do, I think last time I put a little parallel on it or something. Putting a 1, 2, 3 block on here. These are magnetic, so this thing will stay on the top, which means, and I don't think, a degree or two matters. Okay, that looks right. Let's snug it down. And let's just put this back on here and let it sit for a second. Looks like 44, 45. Sweet. We programmed the threading in Fusion, but I have a hard time. In this instance, I can't get the tool to work on the X negative side in Fusion, and I just don't feel like messing with it. So we're going to handle or use it to do Path Pilot, which actually, honestly, the Path Pilot conversational on the lathe is friggin' great. So that's our major diameter, that's our minor diameter, and I'm going to cut it the thread pitch of 0.26 and 12 passes. The rest of this is mostly really noise. So I am way too much of a wimp to cut up our, what I would say is pretty darn beautiful piece here. That's the real deal. So let's cut a test thread first. Whoops. This looks much better. Here goes nothing. Oh boy, I think it's gonna be okay. Gosh, that tool does a pretty darn good job making a chip. I'll be curious to see on the camera, maybe we can see if there's any deflection when we kind of look slow-mo. But yes, awesome. You look at the top of the chuck, man, it's close to the turret. Should be fine, but whew. A beautiful chip. I'd actually love to hear what you guys think. Maybe there's, it's not breaking. It's only breaking to the end of the path, so there's no intermittent break, but it doesn't really matter given the short length of the thread. And it just looks nice. You can hear, you can see the cut's not tearing. The chip forming is forming consistently. It's curling off. Awesome. Whew. Sweet. That was a win.